When it comes to applying permissions in SQL Server, a specific algorithm is used for checking what are known as effective permissions. Database users may belong to multiple roles that have conflicting permissions. As a result, SQL Server needs to evaluate the correct permissions for the user and then determine whether they have access to the securable they are attempting to work with. The security check algorithm used by SQL is complex, and the complexity comes from the need to evaluate group or role membership as well as explicit and implicit permissions. SQL Server will first ensure that all permissions associated with a principal and the securable are taken into consideration. SQL Server permission checking entails three core elements. The first is the security context. This is related to the user, the login, or the role. So as an example, as we expand security, the security context could apply to the logins. In this case, the system administrator account or perhaps any of the Windows accounts that we have existing on this server. However, because the database level also allows user accounts to exist, expanding the security there and taking a look at the users that are a part of the database level also shows that SQL Server needs to take that security context into consideration as well. Next comes the permission space. The permission space will focus around the securable, such as the database object that the user is attempting to access. SQL Server checks the permissions that the principal has been assigned according to that securable. As an example, if we were to expand a table or any of the system tables in our master database and view the properties and check the permissions, this is the permission space for that specific securable in SQL Server. The final core element is the required permissions. This is an important step because some tasks require more than one permission. A good example is if a user was attempting to execute a stored procedure. The execute permission would be required in the stored procedure itself, but actions taken within the stored procedure, such as inserting, updating, or deleting data in a table, would also require that the user executing the stored procedure have those permissions on that table. So the general steps taken by the SQL Server security algorithm are as follows. If the user is a member of the sysadmin fixed server role, or if the user is a member of the DBO role, which is the database owner role, permission checking is bypassed because by default all permissions are assigned to these roles. If the login is not a member of the sysadmin or DBO roles, then the check for ownership chaining is what takes place in the algorithm next. Ownership chaining exists when specific permissions are applied at nested group levels or within nested roles. Once this step has been completed, the algorithm then will check the security context for the user by aggregating all of the permissions from the server and the database level. Remember, a user can be assigned specific permissions at the server level, as we can see by going into the properties, double-checking what server roles the user is a member of, checking on the user mapping for specific server-level items, and also checking for securables that the user may be assigned to. These generate the security context for the user. This is at the server level. The user may also have specific permissions assigned at the database level, which then creates another security context again that SQL Server needs to evaluate. As we look at the properties for that same user at the database level, we can see that the securables are not currently listed because we have applied none in this particular instance of the database, even though this user has securables applied at the server level. Once the security context has been established, SQL Server then goes through the process of checking for the specific permissions. Once again, as we step into the securables page from the login properties for Tom at the server level, looking in the lower portion of the login properties dialog box for the user Tom, we can see where explicit permissions would be assigned for this specific instance of SQL Server. The algorithm will search through all of the explicit permissions to see if there are any deny permissions applied to this specific user. The deny column would indicate with a checkbox any deny permissions applied to this user. Once that check is finished, the algorithm then will identify any of the required permissions for the access requested and see if those permissions have been granted or not by a checkbox indicated in the grant column. If none of the required permissions are met, or if any deny permissions are explicitly provided for the action the user is attempting, the check will fail and the user will not be able to complete the action. However, if the permissions work fine, and if there are no specific denials, then the user will be granted the permission. When assigning permissions in SQL Server, if you're unsure of how the algorithm might work out, apply the permissions that you think you need for this particular user, and then coming into the login properties for that user, clicking the Effective tab will provide you the answer to how SQL Server has evaluated any of the permissions applied to this user for the specific securable selected. Permissions checking is complex in SQL Server due to the way permissions are applied. Groups, roles, explicit, implicit, and individual permissions are all considered to create a security context and grant permission for the user. Specific deny permissions will overrule all other permissions. Understanding this algorithm will help you understand why security checks may fail, or even perhaps why a user is able to access something you thought they were not able to access before. Make use of the effective permissions dialog to validate the security you have put in place.